start. Welcome members to the next part of the lecture, and we're still considering the components of a hydroelectric power plant. Those that have come late, I can give you a brief of what we covered in the first lecture. We started with renewable energy, simple concepts, and under this we looked at, we explained that renewable energy sources are those which can easily be replenished, okay? And they are essentially inexhaustible, and they are unlimited, and we can easily replenish. They can easily be replenished naturally. Such renewable energy sources I talked about: wind, water, sun, bioenergy. My colleagues, Professor Wilson and the professor for solar, I've tried to cover a number of concepts, but in this course, I cover the concepts that are related to electricity production. And I'll take you through hydropower as well as wind energy. So we say that hydropower is then also a source of renewable energy, and how it's harnessed. It's harnessed from moving water, and from that moving water, we have the moving water at a certain potential energy. We derive the conditions for the power output from a hydropower plant, and we say that the potential energy is mass times gravity times height, but we came on to derive the formula for power. That power was directly proportional. That power was directly proportional to the head as well as the flow rate, or the volumetric flow rate. Then after that, that gave us an insight into how much power we can harness from an hydroelectric power plant. Then I looked at the structure of a hydroelectric power plant, where we had the power bay or the reservoir. Then we had an intake area for the water. Then we had the water going through a penstock, and the water reaching the reaching the turbines. We also described that the turbines were coupled directly onto the electrical components of the generator, and then the electromagnetic action within the generator of having a magnetic field cutting through conductors. So in the electromagnetic field was generated by the poles on the rotor, and we also had stator coils. So that interaction and movement of the magnetic field cutting conductors led to the production of electricity. We said after the electricity is generated, it's processed using transformers and put onto the transmission lines. After looking at that structure, we came and looked also at the classification of hydropower plants. Then we said that the hydropower plants can be classified using so far two basic classifications. One was on the basis of the hydraulic characteristics of the power plant, and I said we have the run of the river, we have the storage plants, and we have the pumped storage plants. I talked about the run of the river, where we divert water from a river flowing, and this happens where we have a little pondage upstream. Then that water is directed to the penstock through a canal, maybe, or through penstocks, and directed to the machine. Then looked at the storage plants. I gave an example of the run of the river in Uganda, that's Karuma. Then I went to the storage plants, and in the storage plants, the other name for storage plants was called also impounded as well as reservoir developments. So looked at this, where we just have a dam, then you have an upstream and downstream, and water is passed through that penstock. We say that their heads are a bit low, and then lastly we looked at pumped storage. Under pumped storage is where we said that under periods of low peak, we can have the water being pumped back upstream to supply bigger loads at peak hours. Then we went to the next classification, and we said that they are classified based on the head. And here we have the low head, we had the medium head, we had also the high head. The low head was less than 15 meters. Then we had the medium head varying between 15 and 60 meters. And then we had the high head scheme of more than 60 meters. After that kind of classification, then we looked at the principal components of a hydropower plant. Then I explained the penstock, I explained the penstock gates, I explained the surge tank, as well as the tail race channel. So under these major components, we also looked at the forward bay, where we said that the forward bay is just like a basin that stores the water upstream. Then we also looked at the intake structures, and here we looked at a number of parts like the trash racks that remove the debris. Then we looked at the floating broom, which can remove bigger particles that can float on water, like water hyphene, so that they don't make their way to the gates. Otherwise, if they reach the gates, then they can affect the operation of the system. So after the intake, we looked at the penstock, and we said the penstock is the penstock was a pipe that directs the water directly to the machine. Then also we looked at the surge tank. The surge tank, I said it was a cylindrical chamber that was open to the atmosphere and connected the penstock as close to the powerhouse as possible. I talked about the importance of this surge tank. As who are joining, please mute your microphones. I talked about the importance of the surge tank, and I said to reduce the pressure fluctuation within the conduit pipe considerably. And this helps to prevent water hammer from being exerted on the wall of the conduit. So it helps to protect the penstock, in other words. So after talking about the surge tank, then we talked about the turbines. And here under turbines, I told you there were two types of turbines. I talked about the impulsive turbines and as well as the reaction turbines. Impulsive comes from the word impulse, and the other name is velocity turbines. And this one is made use of the velocity of the turbine, of the water flow. So I gave an example of impulse turbines. That was the Pelton turbine, which had caps, and those caps were connected to a runner. The caps are connected to a runner. So at the end of the penstock, I have a jet of water. So the jet of water hits the penstock and they start to rotate. And as they rotate with the runner, which runner is directly coupled onto the generator, generate electricity. Then I also gave an exploded picture and a cross section of an example of a reaction turbine. I gave an example of the Kaplan, and I said this one makes use of the velocity of the water as well as the pressure difference. So the reaction turbine was submerged in water, fully submerged, unlike the impulse turbines, and the reaction of the pressure difference as well as the velocity of water led to the runner rotate, and that runner was connected to a shaft that was connected to the rotor of the generator. After the turbines, we came direct to the powerhouse. So this is where we are. That was a summary for members who didn't join earlier with us. Members who are joining, please remember to mute your microphones. Otherwise, they are causing bad background noise. So what is a powerhouse? A powerhouse is just like the way you see it, house and power. It's a building which houses the powerhouse is a building which consists of a substructure to support both hydraulic and electric equipment. So the basic use of that powerhouse is to protect the equipment from atmospheric conditions, okay? So the super that powerhouse housed the electrical equipment. Some of the electrical equipment included the generators. It included a number of hoisting cranes. It includes a number of the powerhouse has the transformers. It has all the basic equipment to process the electric power. This is an example of the powerhouse. So we've looked basically at the basics of hydropower energy, and why should we take up hydropower energy? So these are the merits and the disadvantages of hydroelectric power. So we shall start with the advantages. First of all, it's a renewable source of energy. So once it's constructed, produces electricity at a constant rate. And if we don't need the electricity, we have the sluice gates, which we can use to shut down the generation, and we can save the water for other, when the electricity demand is high, or it can be used for other applications like irrigation. Then the dams are also designed to last for many decades, so they can contribute for power for a longer time. Okay, they're long lasting. Then the reservoir that forms behind the dam can also be used for tourism, okay, and other recreational uses. And then the reservoir water also can be also applied for irrigation. Then it being a non-renewable source, it's non-polluting, and it has a low cost, since it's the maintenance costs are so low, and also the cost of operating the plant. What are some of the shortcomings of hydropower plant development? It's hard to acquire land, because once we construct the dam, then all the regions upstream, the river tries to swell, okay? So the river expands upstream, and once it expands upstream, it tries to submerge people's land, crops, and now we have a lot of issues which can be political, some can be environmental or social, in the process of acquiring land for development of hydropower plants. Then the plant also takes a long time for clearance, and it's also, you need to rehabilitate and resettle the displaced people wherever you're developing a hydropower plant, because most of the land also gets submerged, as we have said before. Then also, since we've said that it has low maintenance costs, but the initial investments are usually so high. Now, if you look at, for the case of Uganda, we need to borrow huge loans from overseas, like in China, to develop our hydropower plants. So initially, it requires a very huge investment, and that's a disadvantage. Then the high cost of the dam construction, the high initial cost means that they must operate for many years. You need to operate it for very many years for you to get profitability out of it. Then also, because we have submerged the number of we have submerged the land upstream, then it impacts also on the natural environment. So it destroys vegetation. Vegetation is destroyed. Then it has a system on it has effects on the ecosystem. Then the aquatic life also, like the fish, are also affected, because they cannot swim from one side to the other side. However, some measures are put in place to mitigate some of the impacts of the hydro power plant on the environment. So building of dams also can cause serious geological damages. So lastly, we've seen that hydroelectricity is a renewable source of energy, and countries should try to develop it so as to meet their economic objectives without impacting seriously on the environment. So hydropower helps us to do that, unlike fossil fuels like petroleum products. This is the end of the second segment of this lecture. I'm going to stop the recording and I'm going to allow you to enable your microphones if you have a comment. And I'm also going to communicate about the next lecture we have, as well as the exam. Thank you very much for attending this lecture. Bye.